Hello, folks. It's Professor Fiore back once again. Today I've got something relatively simple, but actually pretty interesting for you. It's a little device that I picked up, a freebie, probably 20, 25 years ago, maybe. And we're going to take a look at it. All right, what the heck is this thing? Well, first of all, it's actually quite small. This little thing, American Digital, is maybe 4 centimeters by 3 centimeters, so about an inch and a half long. Okay, not somewhere around an inch plus wide. Essentially, it's a key ring light. Right, so here's the key ring. You know, back when cars had keys that were just simple metal things rather than the modern clunky fobs that we have. This little thing was designed as a little light, so at night you could illuminate the key entry on your car, or the front door of your apartment, or whatever the heck it was. There's just a little switch down here at the bottom to turn this thing on and off, and over here there's a couple of LEDs that shine out. Right, so it's a tiny little thing that you use as a key fob, basically. Interestingly, instead of just using a simple like coin cell battery, this thing has a little built-in generator. And what we see here at the top, this little black thing pops out. This is a little hand crank. All right, so I'll give you another view on this so you can see a better angle. All right, so here we go. You can see the handle here popped out. So you would just grab this and sort of spin it around, and that would generate a voltage for this thing. Interesting that this was called American Digital, and here's the stamp for China on the back. But nonetheless, here's the 2 LEDs that would light up, right? So, what ends up happening here is, you like I said, you crank the thing, generates a voltage, you get an LED. Now, you don't have to stand there and crank this, okay? Maybe a slightly better view on this from a different angle. Maybe you can see this a little better. So there's the crank. There's the 2 LEDs coming out with this lovely high quality reflector right around the LEDs. So what's actually inside this thing, right? When you crank this, there's a little itty bitty tiny motor, and that is going to generate sort of a sinusoidal waveform, which we will then rectify and drive a little rechargeable battery. And when you flick the thing on, obviously, we connect the battery to the LEDs, and the LEDs turn on. So instead of running out and getting new batteries after you've used this several times, you just pop out the little crank and you crank it around for 20 or 30 seconds, and that's enough to charge up the battery, and off you go for several more uses. All right. So what's inside, right? You take off the screws that hold this thing together. What do we find inside? Like, how complicated is this thing? Okay. Remember, this was just a little freebie that I picked up. Well, this is it. I mean, there's not much here. Now, here's the LEDs. Okay. This is a little motor. Here's the gear for it. This is what's connected to that black handle. So when you crank that handle, this thing spins around. This creates the waveform, right? Basically a little sinusoidal waveform. The output of this runs into a little glass rectifier diode, right? You can see the anode-cathode orientation on this, which then feeds this green thing, which at first glance you might think is just a capacitor, but it's not. This is a small nickel metal hydride rechargeable battery. In fact, you can see right here it says 20 milliamp hours. This is pretty small, 20 milliamp hours. I mean, even a small AAA rechargeable is going to be several hundred milliamp hours. But let's be honest, how much juice do you really need for a couple of LEDs? And how long do you really have it on, right? I mean, you're not going to use this thing to illuminate your front door lock or your car door lock for 5-10 minutes, okay? So coming out of the back of this, right, we just have the hot signal, the hot side of it going out through the diode. And we've got the ground going to the back side, which is just soldered to this little battery here. This only produces a few volts. right? As a matter of fact, this battery is only rated for 3.6 volts. So what ends up happening is you do a half-wave rectification on it, right? So this gets rid of the negative half-wave. So what you have coming into the battery is a pulsating DC, right? Just the positive pieces. Of course, you lose 7/10, 6/10 on the diode, but you crank this thing around, and as long as you're cranking it, this is generating a voltage, it's producing a current, and you're charging up this battery. All right, and then when you flick the switch, the battery is connected to the LEDs, LEDs light up. You leave it on long enough, all right, this drains down to nothing. You come back, recrank this, and the process repeats. Now you might wonder, okay, this is pretty simple, right? I mean, you've got a little generator, basically, this tiny little motor, one diode, one battery, a couple of LEDs that are in series. Why didn't they choose to use something a little bit more efficient in terms of like a full wave bridge, right? Because if you're using a half wave rectifier, you're only getting half the signal. Why not just put in 3 more diodes, for example, and use a full wave bridge rectifier? Well, it's really doesn't come out to be that much more efficient, if efficient at all, because in fact, you have to remember that if you had a full wave bridge, you're going to lose 6 or 7 tenths across each diode. So here you're going to lose 6 or 7 tenths, period. If you had a bridge, you're going to lose 2 of those, right? You're going to lose, upwards to, 1.25 volts, 1.5 thereabout. So, you have to balance that against getting the other half of the sine wave. This turns out to be, pretty much just as effective, and it's simpler. You only have the one diode. And like I said, how much do you really need here? It's not you're not creating like a floodlight or something. You have to be very efficient about it. This is just a little pocket thing that you have, and you crank it up. And like I said, this will last for a good long time before you have to crank it again. The nice thing is you don't have to go out and buy new batteries, right? It's a self-contained little thing, and that's the end of it. Okay. So I thought it's kind of neat because it's such a simple little device. And you can see exactly what's going on here. You have your AC generator, you got your half-wave rectifier, got a battery to charge up, and then a switch to connect the battery instead to the LEDs. Just a pair of LEDs pulling right off of this so they light up. Remember, LEDs, forward drop on LED is more than a rectifying diode, right? Depending on the kind of LED, the color, you might be looking at 1.5 volts, 2 volts forward drop. So you can just put a pair of these in series, and that'll be sufficient for this battery. You're not looking for highly regulated light output or anything like that. Just something very simple, right? When it starts to get dim, you just start to crank it more, and off you go from there, right? Okay, pretty simple, pretty cheap, pretty cool. Next time.